Hi guys, how are you?
Good.
Hello, hello. I really like this intro about how the world is connected. So it's very good stuff. Yes, we're connecting you from Europe and US. Yep.
Mitya, very nice T-shirt. I can't wear one because the black is forbidden in a studio. But you can.
You see, I have this very special hardware Hawaii. This is Hawaii. Yes, exactly. It's Hawaii. Background. So now I'm able to do this, and I'm very grateful for getting this T-shirt from my previous J-Point. So thank you very much for the organizers. It's a pleasure and honor to wear it. Yeah.
I don't have J-Point. I don't have J-Point T-shirts, so I had to celebrate our Super Bowl victory still. I guess until next February.
It's cool. I would like to introduce Dmytry Alexandrov, our first speaker and also expert of this talk. Mitya is first, it's our big friend. And he is co-leader of Bulgarian Java user group, Java champion, I guess Java champion, and also Oracle groundbreaker. And
also
for now, Mitya works in Oracle, and he's alumni of this community. Mitya, could you please introduce your colleague, Alex?
Oh, yes. So, Alex. So great pleasure to be here again with you, at least virtually. Hope to see you live, maybe even this year. So, yes, and I'm together with my very good friend and colleague Alex Seovic, who is an architect from Oracle.
Hello.
Yes, he's now in a very good weather somewhere, so in Florida.
Nice and sunny.
Nice and sunny, yes. So we can envy him officially about it. So Alex is an architect. He is architecting Coherence project. And actually together, today we will present you both Helidon and Coherence. So how can they live together? And, we will get the benefits from each other, I would say.
Cool. And I guess we're ready to start, and stage is yours, guys.
Thank you.
Okay.
Mitya, take it on.
Yes, I will take it on. So, there will be like a small presentation at the beginning from both of us, and that will be a lot of live coding. So this is what we actually love about this presentation, about the quantity of time that we have. And that will be a lot of coding. Just to say you that it's in English. This talk is in English, but I, can read on and answer Russian questions. So when you write something in chat and I'm available, I will translate it. So don't hesitate. Use the language of your choice, and I'm here to help you with that. So yes. Let us actually start. So today we're going to talk about building scalable microservices for Java with Helidon and Coherence Community Edition. So once again, Dmitry and Alex are here for you. So, everything changes very fast. And, before taking your business decisions, always check what's available to you, what product is available to you. We will start with the foundation for today's talk, and it is the project Helidon. Probably you have heard about it, but if somebody did not hear about it, I will tell you a few words. So what is Helidon? Helidon is actually, we position ourselves as a set of Java libraries for developing microservices, and all of the information you can find on our helidon.io website. You probably, from the tweets, maybe from many other talks, that Helidon is translated from Greek as swallow, this wonderful bird, which is like very fast, very maneuverable. And for me, it's a wonderful representation of what actually microservice is. By the way, on the website, you see this small bird here. this is our symbol, and we call him Frank. Yes. So the best part of Helidon, actually, although it's mostly driven by Oracle, is that it is completely open source and distributed Apache 2.0 license. That means that all the code is in GitHub and is available to you. And whenever you want to understand how it works, it's not closed source, it's open source, and we highly enjoy when somebody contributes, by the way. So we accept PRs, so we usually say not thanks, but just PRs. And what is it actually? So we are built on top of Netty. That makes us very reactive and very fast. So set of libraries around Netty. And as we say, our main idea is to serve microservices, and that's why actually we are cloud native ready. So because most microservices are in clouds right now. So out of the box, when you download Helidon or use Helidon as a dependency, you get breast health metrics tracing, everything you need to deliver you cloud native experience of using microservices. So we are cloud native ready. And more than that, we are like proud of the fact that we are very GraalVM native image compatible. That means that everything, almost everything of the code we have can be compiled to native image and makes the sizes really, really small. So it's really great. Another remark, which is like, well, it's really affecting your business decision, is that we are Java 11 plus. That means absolutely no compromises from our side. We are modular. We are enjoying the best of newest versions of Java. We are implementing them, and we are like, really on the leading edge of Java itself. So no compromises. We're Java 11 plus. Just a small overview what actually Helidon is, once again. So as we said, a bit on top of Netty. And then there is a special layer of actually all this wiring around Netty to deliver you microservices. It is actually fully reactive. We call it Helidon SE. And on top of it, there is what we call MicroProfile Helidon specification. So as you said, we are a set of libraries, but we are mostly focused on MicroProfile. That means standard is something that we push forward. That means that the ecosystem we are living in is standard, and it's represented by MicroProfile. Let us actually take a look what Helidon MP is. And by the way, it's in our cases, we believe that this is the preferred way of doing stuff. Like, it solves most of your problems in MicroProfile way. What is MicroProfile? Somebody who knows me actually know that a few years ago I presented this talk on Joker conference. So MicroProfile is an open source community specification for enterprise microservices. It started only from out of actually 3 specifications. So some of the big vendors just sat together and said we need to make it standard way, and they said that 3 specifications will be like enough, but actually it grew up to much more, and now it is hosted under Eclipse foundations, and it has a very high cadence. That means 4 releases per year. As I said, we started only with 3 specifications. Now we have like 12 specifications, which are specially designed for microservices, and all the microservices world. That means from box you have open tracing for tracing, because like microservices system is distributed to get API for documenting metrics, like health checks, of course JSON-P and JSON-B to pass your JSON file, because like JSON is the most commonly used format for exchange between microservices, and of course fault tolerance, because once again, microservices is a distributed system, everything can fail. And where is actually Helidon here? So as we say, we are MicroProfile, but not only MicroProfile. So we support all the specifications up till 4, by the way. So we have to like be released very soon with full 4.0 MicroProfile support. Once again, just to say that MicroProfile is not an implementation, it's just a set of specifications that we as a vendor implement. Other vendors can implement it in their own way, but the code itself is portable. That means that you can run on one server and, for example, migrate to Helidon, and the code will be totally working. So once again, we support MicroProfile. There are some additional specifications so that are part of like MicroProfile, but not yet like in the full spec. So like GraphQL, for example, we already support it. And of course, we have something which is Helidon specific, like Coherence and gRPC, because of the high demand of the community that it uses. But just to be like I said about this reactive stuff, Helidon SE, what is Helidon SE? Just to mention it, instead of hiding all this reactive stuff that we have underneath, we said, okay, we will give our users a full backstage support. That means full backstage pass. Like, in a concert, you also have this backstage pass. And this is actually our danger and challenge zone, because Helidon SE is the reactive set of only pure Java components, let us say. Once again, we fully support everything which is underneath MicroProfile, so you still have config, tracing, gRPC cores. We have some additional stuff like reactive support, like reactive stream messaging, very nice web client, and even a DB client, which is one of the, you see, something makes us proud, because it's like a wrapper client to make all of the synchronous database drivers run asynchronously. So we made it like this, and delivers you a reactive way of talking to databases, even if they are made up the old blocking way. So just check it. And once again, Helidon MP is MicroProfile way of doing things. So it's like you said, have the standard annotations and you use them. Helidon SE, on the other way, is pure Java. That means that you're using everything which is Java only. We have practically no annotations, maybe override, by the way. And you do everything just by code. So it's extremely fast and extremely debuggable. So yes, if you want more information, there will be a link about other talks about Helidon. There was one, by the way, in Snow One conference earlier this year, so just check it out. Basically, this is all you need to know about Helidon for now. This is enough for us. Now, Alex, I think it's a good idea to tell about something about coherence.
Sure. Thank you, Dmitry. So a number of years ago, back in 2005 or so, I think Geir Magnusson jokingly said that Coherence is the most expensive enterprise hash map in the world. And it was funny because it was actually true at the time. It was expensive and it was enterprise hash map, so to say. But it's not true for a couple of reasons anymore. For one, it is now free. We've open sourced Coherence Community Edition last June, and we've been working on a lot of new features, adding them to Community Edition, like support for Helidon, et cetera, et cetera. So go to the next slide, please.
Yes, please, the producer, bring us the slides. So we still have the slides to show. Yes, thank you. Yes.
All right. So what is Coherence? If you're familiar with it, or not, Coherence is the first in-memory data grid. It created a space back in 2001. So it's the product that's been around for almost 20 years now. But surprisingly, it is incredibly well suited for modern cloud applications, because some of the things that we are doing today in Kubernetes, like scaling things out completely in an elastic fashion, Coherence has supported that from the very beginning. It was actually designed and built as a product that can scale out and scale in on demand as you need it. Right? It is also a Java library. Some people think that it is a server that you talk to, kind of like Redis or Memcached, and it really isn't. It's really a library. It can turn any Java process into a cluster member. It can use it to store the data. And it can do a lot of other things. But the fact that it is a library makes it embeddable into any Java SE application, including Helidon application, which is what we will demonstrate here. It is also very easy to deploy and scale in Kubernetes using Coherence operator for Kubernetes, and we'll demonstrate that a bit later. that's kind of the whole point of this talk. I mean, how easy it is to scale stateful applications built using Coherence and Helidon in a Kubernetes cluster in any cloud environment. And it's also easy because of support both in Coherence and in Helidon. It's also easy to monitor with Prometheus, Grafana, and Jaeger. We expose Coherence internal Coherence metrics via Helidon metrics endpoint. Prometheus can collect them. We have a set of Grafana dashboards that I'll show a bit later that you can use to monitor Coherence applications, etc. And then we also support open tracing, so you can use Jaeger to see exactly all the way from the front-end request coming to Helidon REST endpoint or gRPC endpoint to going to Coherence and even actually going all the way down to the disk. You can see what's taking time when processing those requests. And as I mentioned earlier, we still have our commercial editions, which have some advanced features, but we've open source community edition last year in June. And that edition is what we are actually using for this demo. And it has all the features that I'm going to be discussing and talking about when we go through the code. And it's perfectly well suited for building cloud applications. We didn't really hold anything back that you need to build these applications and give you like carrot on a stick. We everything that you need to build applications that we are like the one we are showing is there. Next slide, please. So if you are familiar with Coherence, you probably know it as a distributed cache, and that is how it started. And it still supports that, but it's not just a cache. It's actually a lot more. First and foremost is very scalable, fast, general purpose KV data store. It's actually, you can compare it in many ways to MongoDB or any NoSQL data store. You can, put values in it. You can get values from it. You can also query it. You can do aggregations, et cetera, et cetera. So we store data in memory for fast access. I mean, we're always technology that is used to optimize performance of the applications, cache the data from the various backends, whether those are mainframes or databases or web services and whatnot. So we do store data in memory, but we also have the ability, and have had it for the last 5 or 6 years, to persist data to disk. So it's not just in-memory data storage; it can also be used as a durable data store. The way Coherence scales is by partitioning data and processing across all the available cluster members. So by basically scaling out the cluster, you can increase both the capacity and the throughput of the application. It also has some fairly sophisticated features on how we make sure that data is safe. For example, Coherence is aware of network topology in a way, right? So especially in Kubernetes environments, it knows when we are running into multiple availability domains, it knows that we are running in multiple availability domains, which allows it to create backups as far as possible from the primary copy. Because typically, by default, for each primary piece of data that you store in Coherence, we will also create a backup somewhere else. And that somewhere else is kind of important. You don't want to create backup on the same cluster member that's storing your primary piece of data. But we go a step further. We make sure that that backup is created as far as possible. So it will be on a different machine, or if we know more about network topology, it will be on a different track or on a different site, which means different availability domain in this case. And as I mentioned, we support a number of advanced data access features. It's not just gets and puts. It's not just the store. You can do queries across the cluster, which will be executed in parallel. You can do aggregations. You can map reduce operations. You can actually do in-place processing, which I'll go into more detail a bit later when we go into the code. Next slide, please. It is also an event streaming platform. It has had support for both client-side and server-side events for a long time, and we'll actually show an example of that today. We're going to be using events heavily to update different versions of the clients that we have. And we also, since the latest release, we also have built-in pub/sub messaging support. Next slide, please. And yes, it is still a cache. I mean, and a pretty good one at that. I mean, Coherence has literally invented some of the popular caching topologies that you may know and use. So, we have both partitioned and replicated caches. You can limit them by time and size, which is nothing new. I mean, every cache supports that. But it has also support for reading from and writing to backend systems. So you can do read through, write behind, which is asynchronous write through, refresh ahead, which is basically asynchronous refresh. So you don't have to pay the cost of reading something when you actually need it, et cetera, et cetera. So it can integrate with any external system via the cache store and cache loader mechanism. We also support different ways of client-side caching, which optimize read performance for the client. So, for example, if you have a lot of data cached in Coherence, you could also bring subset of the data to each of your clients and have it in memory locally, and it will be kept up to date using what we call continuous queries or materialized views on the client. So you can say, give me all the traits for this particular symbol, or and just basically based on a criteria, you can bring subset of the data to the client to basically have access to it at zero latency. Next slide, please. All right, so that kind of covers the product. I mean, obviously, it barely scratches the surface. We'll provide some resources later on where you can learn more about both Helidon and Coherence. But for now, let's talk about what we are going to do today. We're going to build a very simple, but as you'll see, very, very scalable to-do list application. It is kind of trivial example, but it does allow us to show a number of features that are interesting and don't really change regardless of what type of application you need to build. We'll create some data. We'll create APIs to put data into Coherence, to read data from Coherence using queries and whatnot, to update and delete data, et cetera, et cetera. So we'll do some basic CRUD functionality. And then we'll demonstrate that we have React front end, and we also have JavaFX front end. And we have like a built-in GraphQL front end that will be used to demonstrate GraphQL API. So basically what we're going to build is an application that has 3 different API facades, if you want to call them that way. We will have your run-of-the-mill REST API, which is kind of a starting point. But we'll also, in addition to REST API that the React front-end uses, we will build gRPC API facade, which will be used by the JavaFX client. And we will build GraphQL API facade to the same data that will be used by GraphQL client. So I think that's it for an introduction. Dimitri, please get us started.
Okay, so I will take over. So now, as Alex said, let's do some code. So Helidon is a good foundation for that. So as you say, 3 facades, we need to make them. So they're like microservice, so we will use Helidon for that. How can you use it actually? So first of all, it's just using Maven archetype, which will actually add you just, few dependencies to the code. And that will be enough. That will be like enough for you to start everything. But there's another way, of course. There's this called MicroProfile starter page. So if you start a page, you just go there, choose the right platform. For now, it will be Helidon, of course. And it will generate you the POM file, and you will be able to use it. But we are actually would like to bring you more to our customers, to our clients, to our users. And we have created a special Helidon application, CLI application, which makes everything extremely fast and easy. So you can just download it and use it. Funny thing is, not funny, but good thing actually, that is also written in Java and is distributed as a native image. So it's a native image binary, also written in Java. So, and I have done my homework and I have downloaded it. So let us start a new project. So how you do it? So we just type in Helidon in it. and ask some questions and answer actually some questions. So as you see, there's two flavors for now. So SE like the reactive stuff, and MP for the microprofile way of doing things. So we'll choose microprofile way because it's actually enough for everything. And we will create some so-called bare minimal application. So with minimal setup, but actually runnable. And we will call ourselves like a to-do list application, for example, in a package io.helidon.coherence. Yes, I did write it correctly. Artifact ID will be, of course, to-do list. And snapshot version, Java package name, of course, io.helidon.coherence. .to-do, like for example. It's also inviting us to start a development loop. That means that every change you make, it will recompile and start it for you. So we'll not use it for now because it's not interesting for this demo, but for other Helidon talks, there's a good explanation about it. So what do we have? So it created us a bare minimal application. So if you see it, it's just a typical Maven project. So let us use our favorite IDE and actually see what we can do. So what's the best part of all of that stuff is that we are going to make a lot of coding today. So let us see. So we're loading the project once again. I'm just doing it from the very beginning and very scratch. So that's what makes it really cool. So what do we have here? So source folder, and there's one greeting resource which we actually don't need right now. So we'll just delete it. Okay, let us start. So we have to make a to-do app. So let us create some objects which are necessary for us. So the first one will be task, because to-do app manages tasks. Just a class, and so I have created a small shortcut for us just to save the coding. So what do we have here? We have created that, completed if the task is completed, the ID of the task, and the description, of course, some constructors, some more boilerplate like getters and setters. We definitely need all of them. Of course, so we will follow the basic strategy of all you need for Java is, of course, hash code and equals function, because it will be necessary for distinguishing the tasks. And the last but not least is, of course, the toString. Lovely. So very fast, the task is complete. The next thing we should do is a service. So the service actually manages the to-do tasks, the to-do lists. So it's to-do list service. Once again, it should be quite fast and easy to do. Small short task, shortcut to-do list service. So what would actually it create? So let me just format it. So we will have the create task. That it returns as a task. We will have a collection of tasks. So to get all the tasks, we can find the task, and delete completed task, update description, and update completion status. So for now, it just returns null because we will then wire it to Coherence. But now this is enough for us. As Alex said, we have to create 3 facades for our microservice actually. So the first one will be REST, and REST, yes. And the service we will call it like to do rest list, no, to-do list, wait a minute, list rest API. Man, this is a bit hard. So first of all, it has to be application scoped. So it's enough for us. Application scoped, yes. So we are now using enterprise stuff here. And we have to actually, well, inject our service, because our to-do list service is like a private and to-do list service REST API, called just API. And then, don't get me wrong, but I have some more shortcuts just to save your time, which is like, it creates us, let us add some dependencies, of course, REST dependencies. So I've done my homework, and that's why it will be like not so reddish here. Like, oh, actually not this one, but we will use it later. So what we have here, so we have post method that creates a task. We have a get method that creates a collection of tasks. Delete methods. Of course, put method to update the tasks. And as you probably may see, it's MicroProfile specific tags or not tags annotations. And this is how easy you actually can do the RESTful stuff. So once again, as Alex said, we also need to do some SSE, like server-side events. And once again, it's very easy. So you just create an SSE in a context, add the broadcaster, and every time we create an event, we broadcast that we create the event so that other platforms can see it. So Alex will fill it in a little bit later. Alex is watching, so like, yes, lovely. But we'll do more than that. So as I said, we need to make 3 facades. So the REST facade is almost ready, just something to be filled in terms of persistence here. We will do the GraphQL facade. So GraphQL, and then to do list GraphQL API, QL small l, API. It's just a class. The only thing, we should add some dependencies here. As you see, the only one that we have right now is MicroProfile, and it's absolutely okay for the REST stuff. But for the other stuff, let's add some MicroProfile to say GraphQL, and later we will use gRPC stuff. So it will be quite easy. Let us now add some code, which is GraphQL. Great, GraphQL. It's practically the same stuff as we see here. So it's GraphQL dependencies. Yes, so a few dependencies like queries. Yes, we have to update our Maven to make it run. So once again, we have the to-do list that we do inject. The only thing is, let's just help give ideas some time to add it. Yes, you see now it works. So almost the same functions, but just with a little bit different set of annotations. Instead of like, get put, we get mutation for something which is mutating, and queries for collections of tasks. And once again, query. So something which changes is mutation, something that we read is query. The only thing we need to do to annotate this class is, once again, is application scoped, and of course, GraphQL API. GraphQL API. Yep. And this is the endpoint which is ready. Once again, we're using the service. Last but not least, I'll do this quick, I promise, is the gRPC stuff. So once again, we're following absolutely the same pattern, which makes us really cool. gRPC, and then we have to to-do list gRPC API. Once again, I have some shortcuts, which is gRPC, which makes us almost the same stuff. We only have to make some dependencies. gRPC deps. Yes. Once again, we inject our query, and then, as you see, instead of like mutation and so on, we just put another set of annotations like unary, like streaming for the stream of task, and other are unary operations. And the last but not least is just to put in the right annotation so that gRPC, yes, and it has a name actually, like example to the list. So we are almost there. Example to list. So this is the foundation. Once again, we have the task, we have the to-do list service, which actually manages, which actually manages everything, like create task, delete task. Then we have different representation points, which are REST endpoint, GraphQL endpoint, and gRPC endpoint. And Helidon is there to help you and see how easy it is. And now, actually, we have to add some caching persistent to the state. And Coherence is the best choice, and that's why Alex will now take over from his code. Now, please, the producer, switch the screen. I stop my sharing. Alex, start his sharing.
Thank you, Mitya.
Lovely. So this is the state where I left the code, and Alex will take over.
Is it presenting? Yeah, perfect. Thank you. So I'm gonna cheat a bit. It's not exactly where Mitya left off. There is some additional stuff here. There is, for example, a web front end that has both the GraphQL UI and the React UI that we will be using for the application. I mean, it's not in the scope of this presentation to go into details on how to build that. So we just added them, and they will be built and packaged as part of this application, and will be served by Helidon as static content. So we basically have Helidon configuration here that says that we are going to serve everything from the web directory as a static content. So that's one thing that's here. The other thing is, well, the other stuff we need to build. So that's one thing we were changing. Oh yeah, actually we have Kubernetes deployment files. We'll review those later, but we're not gonna write them as part of the demo. So I'll go over them a bit later. So let's start by adding, obviously we want to use Coherence as our backend. So we need to add some Coherence dependencies as well. So we will add Coherence BOM. And it basically uses the latest milestone version of Coherence. This is version 21 Coherence CE, which is 2106 milestone 1. The final release is due to be out in June. So we use some features that were added in 2106. So that's why we need to use this particular version. Then we also need to add, now that we have BOM defined, we will add a couple Coherence dependencies here. Okay, so we're adding a couple different dependencies. For one, we're adding Coherence CDI server. Coherence CDI server will allow us, will bootstrap Coherence. It basically provides Coherence CDI extension, which will be discovered by Helidon when the Helidon starts, and Coherence will be started as part of Helidon startup process. or actually as part of CDI startup process. So that's one thing. It also allows us to inject coherence artifacts, such as named maps and caches and whatnot into CDI beans. The second thing we have is a coherence gRPC proxy, which we actually probably don't even need anymore, but it's still there. It basically provides a way for native clients, remote native clients, to connect to Coherence cluster over gRPC. So we'll run it. And then we have support for MicroProfile config and MicroProfile metrics. And these two modules allow us to integrate with Helidon configuration mechanism or Eclipse MicroProfile mechanism that are implemented by Helidon, and with and allow us to expose coherence metrics via Helidon metrics endpoint, which will then be scraped by Prometheus and Grafana and so on. So I probably need to refresh this to get the dependencies working before I can do any coding. So while this is working, we need to make a couple changes to the task class that Dmitry created earlier. So the first thing we're going to do is add support for coherence portable serialization, portable type serialization. So we will make this a portable type. You have to wait for IntelliJ. Let it catch up.
Oh, I see. This consumes a lot of resources, like streaming.
Yeah, it's ridiculously slow. I'm missing something.
Okay, just but as far as I see, maybe idea is I know this presentation demons are always here. Yes.
Yeah. And when my machine gets shot like this, it's no fun. All right. Hopefully it won't take too much time. We do have finished demo in case we cannot go through the coding. It would be nice to do it this way, but if we can't, we'll have to switch over.
Yeah, so now our training session
27 minutes. Let's switch over because this doesn't seem. I mean, the resources are just shot here. So I'll switch to what the final demo will look like, and this is what it looks like. So I'll walk you through the code and explain. So
just the producers, please show the screen. Yes, now we can see it. Yes.
Okay. So I made this task class a portable type. This allows us to support a very optimized serialization format that Coherence supports natively. And to do that, we actually had to do a couple of things. We had to annotate class with a portable type, give it a type ID, and then mark the fields that we want to have serialized with portable annotation. So that's one thing that we did there. And in order for this to work, we also have to, because there is a code that needs to be implemented for serialization. And to do that, we have a plugin that is configured here, which is Coherence POF Maven plugin that will actually instrument this class at build time and add serialization code to it. So that was what we had to do for a task class itself. Then the second part is we actually implemented this task repository. right? So we implement this task repository class, which is something that we've added in Coherence 2106 M1, and one of the reasons why we are using M1, which is basically a domain-driven design way of implementing repository of tasks. So we extend this abstract repository class that is provided by Coherence. We inject tasks named map into it, which is the named map, Coherence named map that we will be storing tasks in. And then we basically implement a couple methods, get map, get ID, and get entity type. So get map actually gives the repository named map that we want to use for storage. Get ID is a function that knows how to extract identity, how to get identity from a given task, and then entity type is task itself. And what we also added here to help us with a service implementation later is this find by completion status method, which will give us all the tasks based on their completion status. So we can pass either a null, in which case we should get all the tasks, or we can pass completed flag, either true or false, in which case we should get only the tasks that have that specific value, right? So this is an example of how you would do something like that with Coherence, right? So we construct a filter. So if completed is null, we construct always filter. Otherwise, we create equal filter by saying that we want all the tasks where tasks get completed is equal to completed, right? And then we call find all method, which is one of the methods provided by this abstract repository class, passing it a filter to query on, as well as the second optional argument, the attribute to sort the results on. So we're basically saying that we want to order these results based on this particular attribute. So now that we have task repository implemented, we can go and finish the to-do list service, right? So to-do list service, we can now inject task repository, and then we implement the methods that Dmitry created skeleton for earlier. So create task is as simple as task save new task, right? And it's really just we'll create a task instance and we pass it to the repository save method, which will store it in Coherence and return it. Get tasks for a given flag, we'll just call the method that we just looked at, the find by completion status method that we implemented inside of our task repository. Find task by ID. Now, this gets a little bit different. Normally, it would just be task find by ID, but in this case, we have a contract that service defines that we want to throw not found exception if the task is not found. Tasks find by ID will simply return null if the task is not there. So we want to make sure if we get null back that we throw not found exception. So as you can see, it's still effectively a one-liner. We're just wrapping it with an optional to throw an exception if it's null. And we do the same thing for delete task. In this case, we call remove by ID, and we want to return the previous value or the removed value, so we can send it back to the client because that's what the contract requires. And then delete completed tasks. We again use filter. In this case, is true task get completed, and we call repository remove all method with that specific criteria, right? And this is the last part, update description and update completion status is where things get a little bit more interesting. So this is a feature that Coherence has that not many other data stores do. And it's basically a way, instead of, typically you have this read, modify, write pattern when you're mutating data with all kinds of data stores, right? You will read something from the database and then modify it within the application, then write it back. Coherence allows you to do it more efficiently. You can basically send a function that you want to invoke on an entry, on an entity that lives somewhere in the cluster. So in this case, we know that we want to update entity with a given ID, and we want to call set description on it, set description method on it, and we want to pass the description to set, right? So that's exactly what we do here. We're basically telling repository to update entity with a given ID, wherever that entity is. It's somewhere in the cluster. Coherence knows where it is. We don't know and don't care. about the exact location. It will update in the primary node, create a backup, and that's it, right? And in this case, it returns the updated value. It returns whatever this function returns. So task set description in this case is implemented as a fluent method, so it will return the task itself. So that's what the end result is going to be. So we will send back to the client task with the updated description as the result of this update description method call. And the same thing happens in update completion status. We are just calling different methods. Now, this is a lot more flexible than this. It's not just that you can call a method on it. I mean, you can actually pass a function, so you can pass a lambda effectively, and that you want to execute against an entity that's somewhere in the cluster, and modify it any way you see fit, and then return whatever you want to return. So there are many different things that you can do this way. So that's the service, right? So now we have the basis set up, and there were a couple things that we still had to do in our GraphQL API. For the most part is done. I think what Mitya did is, I'm not going to make any changes there. It basically stays the way it is. It just calls our service to get the stuff done. But there are a couple things that we still need to do in the REST API and in the gRPC API, and that is to connect events as required, right? So we had a skeleton for the event mechanism. So Mitya set up the SSC context and the broadcaster, right? And now we need to basically add this piece of code, right? So what we want to do is make sure that whenever event happens in Coherence, we basically broadcast that event back to the clients, back to the REST and any REST client connected to this event's endpoint, right? So when we create broadcaster, we also register a listener with Coherence, with our task repository. We will create a listener that will on every insert call broadcast with the insert event and pass the task. And then on update, it will call create update event with a task. On remove, it will create delete event with a task, and it will basically broadcast that back to the clients, right? We also set up when the client first registers for the events endpoint to receive events, we want to notify that the registration was successful, so we can see that happening on a client. So for that, we will actually use Coherence CDI support in this case and simply inject cluster. And then from that cluster, we will get local member. And as part of begin event, we will simply send begin event and member information as a string. So on the client, we can then see which member we actually connected to, which member we are listening to events from. So now that we have events out of the way, the rest of the code is pretty much the same as Mitya left it, right? We're just calling our service and doing different things with it. So the REST API is now done. And we need to do something similar in the gRPC API. Now, gRPC API is a bit more interesting. I think it deserves some more discussion, because one thing that you noticed, I mean, we did gRPC without any protobuf definitions or without even using protocol buffer, and the reason for that is that in this case, Helidon gRPC support allows us to use whatever marshaller we see fit, and protobuf is absolutely supported. It's the default actually, but we can override it. And in this case, we are overriding it to use POF, the same mechanism that Coherence uses to store data inside of the cluster. So we already have our task object our task class that supports portable object format, supports POF. So why not use it for gRPC as well, right? So we are using POF, and then basically you'll notice that we are not dealing in most cases. I think there may be one case when we are dealing directly with a stream observer, and that's when we get to events. But if we want to return a stream of, we can simply, mark method as server streaming and then return stream or a collection, and then it will basically use server streaming gRPC implementation, and it will send stream elements one by one by calling on next on a stream on the gRPC stream observer. For unary methods, we basically just call it once and complete, right? So all of that stuff is handled automatically for you. What that allows you to do is declare your method arguments and return values in terms of actual messages you want to send. So in this case, and you can actually, because POF support, like with protobuf, you would have to create separate message just to represent a string. With POF, you can just simply say that we want to receive a string and we want to send back a task, right? So there is a lot of stuff that Helidon does for you here that you would otherwise have to do using protobuf files and generate code from them, et cetera, et cetera. So the one example that I said we need to use stream observer is actually when we are sending events, and that's because we want to control when onNext is called and what is it called with. So in this case, you'll see that the code is very similar to what we did with in the REST API. We basically add listener to the tasks repository, create a listener, and then on insert, we say that we want to call observer on next. But in this case, we are basically sending now different event types. So these are now, again, these are portable type objects that are defined here, right? So task inserted, task updated, task removed. We just declare them in this class, and they effectively represent our messages that we want to send. And they're just wrappers around the task that add some context around what type of the event it is. We could have obviously implemented them differently and basically send the name of the event and the task as we did in REST, but we decided to do it this way. So that's pretty much it. So we're using POF for the gRPC client and gRPC server to talk. We're sending these events back, et cetera, et cetera. So finally, let's look at how this gets built and deployed. We can build this using. So now, what's important to understand, what I mentioned earlier is Coherence is just a library. In this case, we're going to package everything up into a Docker image using gib plugins. So when we run build using Docker profile, it will use a gib Maven plugin to create image based on distroless Java 11 image. It will add Helidon to it. It will add all Helidon dependencies. It will add Coherence and any of the dependencies we specified in this POM. It will open ports 1408 for the gRPC and 7001 for the REST endpoint and REST and GraphQL, because GraphQL is served on a web server as well. And that's it. It will build a single Docker image that we can then use and we can then deploy in Kubernetes. And if you look at I have actually 2 Kubernetes clusters that I'm deploying this to. The first one is MicroKubernetes, which is running locally in my house. It's basically a cluster of 4 Mac minis, so very limited resources. So I'm only going to deploy a small cluster here just to show you. But then we'll look at a larger cluster when we talk about scalability and monitoring and whatnot. So we're basically we're using Coherence operator. So there is a special CRD. There is Coherence version 1, kind Coherence. So we are basically saying we want to create Coherence deployment called to do. We want to have 3 replicas running in the beginning. This is the image to use, which is the one that we just created using that gib plugin. And we will configure tracing information so we can look at the data from Jaeger. And this is something where Coherence operator actually integrates with Helidon. When we specify application type Helidon, it knows not to run Coherence default cache server as a main, but to run Helidon CDI main as a main class. So it will actually run Helidon. Helidon it will start Coherence. And then we have everything. And then we also have persistence configured. In this case, as I said, because we want this data to be persistent, even if we shut the cluster down and restart it, we want data to be persistent. So we are turning persistence mode to active and basically allocating 1 gigabyte PVC to each of the cluster members. So we are actually running out of time. So let me go into the demo. So this is the cluster I just mentioned. I have 4 Mac Minis. If we look at, I already have this application deployed. So if you look at it, we'll see that we have three replicas already. If we say get pods, you can see that there are 3 to-do list pods. They're backed by a stateful set. Each of those stateful set, each of the pods persists to a PVC, right? So these are the PVC it is bound to. So let's see how the application actually works. So I have all three clients set up here, and we can enter some tasks here. We can enter a task here. We can even create tasks from our GraphQL UI, and it will show up in the other 2 UIs. So think about it. Now we have 3 different clients, right? And whenever I do something in one of them, well, I deleted this, but I can also mark it as checked. I can delete completed tasks using GraphQL API, and every other UI automatically gets updated. This is the power of event-driven mechanism that we just described. So whenever Coherence is updated, the events get propagated to all the clients, and the clients get refreshed. So that's the demo itself. But now let's go back. I mean, as I said, this is all good, and this is running against 3 nodes, but how easy is this to scale? So let's scale, it's just as easy as any stateless application you've probably written before. It's just as easy to scale as plain Helidon application with no coherence in it. So all we need to do is say scale Coherence Deployment to do, and we'll set replicas to 6. And it will say that it's scaled, and it's not going to, it's obviously provisioning PVC. It will take a minute or 2 for it to scale, but you can see that the new pods are being initialized, and it will eventually get to 6 nodes. But 6 nodes are only so useful. We said we can actually scale this properly, right? So this is a cluster that I have running in Oracle Cloud in OK. So it has, I think, 16 or 18 Kubernetes nodes. And it already has a cluster, same application running in a 100-node cluster, I believe. That's where I left it off. Yeah, so we have 100 nodes. So how easy it is to scale? Well, just as easy as the other one, right? So we can scale. I think it's called to-do list here. Because we have more resources, we can scale it to more. And it will take a few minutes for it to scale, but if we look at this, you can see now that it's going to have 200 replicas, 100 of them already, and now it's scaling. So let's leave it do what it's supposed to do, and let's see if this one is done almost. So this should be almost done. It should be at 6 members. So while this is all scaling, let's look at another thing. So I said earlier that we have built-in support for tracing integrated with Helidon. So let's look at we created some tasks. So let's look at post. Okay, so you can see that when we created tasks, Helidon got HTTP request. So this is the request coming to Helidon using API tasks URL. And then you can see Helidon security filter kicking in. But then this is the post to our actual JAX-RS resource, right? This is the post to our create task method. And then that calls Coherence put request. So you can see Coherence put request. You can see that it's being dispatched. And what's interesting here is that you can actually see where it's happening. So this put request was dispatched on member 3, and it was actually processed it was actually processed by member 1 in a partition 189. So I mean, that level of detail you probably don't need, but you can actually see that it's processed on a different member. It was written to the disk, and then it was also backed up in parallel to a different member. And if you see where it's backed up, you will see that it's backed up on member 3. So we did a put from member 3, it created primary copy on member 1, and then backed it up to member 3 itself. So that's an example of a trace. And what's probably more interesting is when you look at things like gets, because then I guess I don't have this. Okay.
Let us take a look at the Grafana. I like the numbers.
Yeah, let's take a look at Grafana. So this is the application running in a large cluster, and this is our Grafana dashboard. So you can see that at the moment we still, actually we are up to 200 members. It just took a minute for Grafana to update. And if you noticed, we went from capacity of 200 some gigabytes with 100 nodes, because I'm running with 2 gigabyte heaps, to 429 gigabytes with 200 nodes, and the number of members spiked, et cetera, et cetera. So you can see cluster members. There are also a number of other dashboards that we probably don't have time for right now, where you can look at how much data is in each cache and how the service is distributing data and things like that, what is the thread utilization, et cetera, et cetera. Probably like 15 or so different dashboards for different pieces of Coherence. But in the interest of time, you can see that we scaled everything, how easy it was to scale. And with that, I will give it back to Dmitry to tell you where to find more information about Helidon.
Oh, yes. By the way, I just want to say that I believe that with this setup, we can serve to-do list of at least 3 planets, like planet Earth, with all population.
Yeah,
I guess.
Definitely not for my wife's to-do list, for me.
Oh, absolutely. Okay, so once again, it was really great. Once again, Helidon is a great foundation for this stuff. By the way, the integration you saw, all this Grafana stuff, all this metrics. So the integration between Coherence and Helidon is really amazing. So thank you. And if you want to learn more about Helidon, so go to helidon.io. Or if you like to read, go to medium.com/Helidon. The code is available under GitHub. If you don't like to read, there's the Oracle YouTube channel. So I don't like the URL, but we still are not able to get the right one. So just type in Helidon, you will see. And if you want to, chat or ask questions, go to helidonstack.com. Russian is accepted as language, so we will answer it in Russian as well. So enjoy. So, Alex?
Yep.
More info about Coherence?
Yep. More info about Coherence. Our Coherence community website is available at coherence.community. You can find some intro material there, as well as links to pretty much everything else that's on this slide. Link to our blog on Medium, link to GitHub, where the source code for Coherence itself is. We also have YouTube channel. We've had it for a while because we've been there, so you can find both some old content and some new content there. And then same thing. I mean, if you have any questions, if you are running into issues and you need some help, you can find us on Slack on oraclecoherence.slack.com.
Yep, and once again, yes, if you have some questions, so let us go to the discussion zone. I believe this is great. I mean, when I think about it, that actually these two products, like Coherence Community Edition, is also free. Helidon is also like free and open source.
Yeah, everything we showed here, you can basically pick it up and use it. Doesn't cost a dime.
This makes it extremely cool that you just pick it up and use it. The licenses are great. I mean, you can see the code. So I believe we're doing just great. Well, thank you so much.
Thank you. Спасибо.
Thank you, guys. a lot of useful examples, and the main thing for me is that you shown in 1 hour how all that stuff works together. I will try it.
Okay, yes.
For now, I would like to invite you to the discussion zone to have a talk with
Sure.
Yes,
We'll be there
okay.
in a minute.
with other guys.
Yep.
Thank you very
See you
much.
there. Yep.
Bye.
Thank you, Андрей. Всем большое спасибо, ждем дискуссионки. Давайте, пока-пока.